the data center part, right? Now, each of these will have multiple different servers. So this is how exactly it's going to look like. So now let's come back and see how do we architect this entire ecosystem, right? So in a real environment, if you want to architect an AWS high availability environment, this is how exactly it's going to look like. Let's make it, let's make it a slightly different shade. And so this is how exactly your environment would look like. Slightly a networking concept, but don't need to deep dive into it. So here, what we're going to create is, in case if you are aware of cloud concepts or traditional data center concept, this is nothing but a DMZ, right? Control C and Control V. Let's change that color slightly, something different, maybe this one. And let's remove this. Yeah, this is how your DMZ would look like. When I say DMZ, it's nothing but your public subnet, right? So I'll name every of these so that you are aware of what exactly am I talking about. And now what let's do is let's create this as a private subnet, which would be like this, or it'll be like this. Okay, let's choose another color. All right, let that be a private subnet. So this is how your entire architecture would look like. Okay, so public, this is public, subnet in fact. So let me just write it down as public. I'm not sure how to change these fonts and all. I'm not sure whether it's possible or not. These both are going to be public subnet, and these are private subnet. Private. This is also private subnet. Yeah. If I make it small and then drag it down a little bit. Okay, so this is how exactly your architecture would look like. Public subnet, and these are nothing but this entire thing is my Mumbai region. Okay, it's Mumbai region, and inside that comes availability zone, which is AZ1 and AZ2. So AZ1 would go over here, and AZ2 would go over here. Let me just finish that architecture so that you can visualize how things works, right? So whenever from your laptop you type in www.gmail.com or maybe some web page, the way it looked like, let's draw your laptop to over here. So that's how that looks like a fancy laptop. I'm just going to make another small. Yeah, think about that. Your desktop or laptop, whatever. Yeah, looks like a desktop, right? Now you type in your www.google.com. What happens is the DNS service available in AWS is known as, let's try to see what shape I can use it. Is it the only shape I can use? I think see so many other. Yeah. So let's pick up one from here. Let that be a doesn't look so great. Okay. And fill or yeah. This is nothing but Route 53. I'm going to write it as R53. It's Route 53. It's a service, which is nothing but a DNS service available in AWS. Let's name it as DNS itself so that you understand. DNS, our GoDaddy, right? So that's where you are going to type in. So this arrow, can I get an arrow? That's an arrow, right? So this is going to go to Route 53, and in Route 53 is going to send the traffic to a load balancer over here. There is slightly a deeper concept in load balancer, but for us to simplify it in a very, very simplistic form, we'll just call it as load balancer. Uh, Load balancer, LB. Elastic load balancer, that's what we call ELB. I'm just going to take this load balancer, and load balancer will sit in between. In reality, it will have one node available over here in the public subnet, one another node sitting inside the an availability zone 2's public subnet. So that's how you bring in high reliability, right? Now what we need to do is let's bring in some servers too over here. Servers, this is my server number 1. Yeah, let's make a slightly smaller one. These are nothing but the web server. Okay, there is, as I said, it's not a very refined architecture. There is a better way of doing it, but for us to start the journey, this is the best way for you to visualize, right? So that means my google.com is hosted inside this particular web server. Also, this particular web server, exact same replica is I'm going to take it up and place it over here also, right? Now, what is the reason for that? We will see. Now, think about this particular. Let's make it as instead of google.com, let's make it as amazon.com, right? So where you make your shopping cart. So one server of Amazon is sitting inside in one subnet, inside one availability zone, next one sitting in the next availability zone. Now, whenever you buy something on a cart, it could be an iPhone, right? iPhone 17, the latest one you want to buy, you put it in the cart, and then you want to make some transaction, right? So in that case, that entry should go inside a database. How does a database look like now? Let's make this as a database, right? Database or your app server needs to, that it's going to sit always on a private subnet, right? So this is going to be my master, and this is going to be my secondary, right? That's how you implement your reliability. Yeah. So what it means is anytime traffic hits, let's bring that scenario. Anytime traffic hits Route 53, Route 53 is going to send, Route 53 is going to send this to, let's take this, to Elastic Load Balancer. That's where your traffic goes first. Based on algorithms available in Elastic Load Balancer, which is round robin or least use resources, right? What happens is it's going to come up with either over here or over here. I'm going to take this, Control C. Yeah, and over here, right? What it means is, in case if this is going to be full, maximum utilization, in round robin fashion, first traffic is going to get over here. That means if I log in, it's going to go into this machine. If you log in, it's going to go into this machine. In a round robin fashion, that's going to get traffic get distributed over here. Now the next part, once that happens, it may go directly over here to the master, and Control C and Control V. It can even happen exactly the same way over here too, right? So that's the master. And now one line needs to get connected with the master and secondary too, right? In case of a failure. So what happens is this is a synchronous replication. Yeah. What do you mean by synchronous replication? The moment a data is getting stored over here, that means in a database, one record is getting inserted, that insertion is going to result even into the secondary, then only an acknowledgement is going to send back to the application stating that return code 200 successful, go back and give an update status back to it, right? So that's exactly what you mean by synchronous transaction. And this is how exactly you create a high available environment in an AWS ecosystem. This is the architecture that it looks like. So each subnet, it's a networking layer. This is a public subnet, and how exactly all these things are created, I will showcase to you in a different video. So hope you get when someone talks about create a high available architecture in AWS, this is exactly what should be there in your as an image in your mind. Yeah, thank you.